Hi, in this video I want to show you how to build a really simple game with Shiny. This game will consist out of only two steps. The first one is that the user gets prompted a street name from a city. In this case that is Ulm, the city I'm living in. And in the second step the user tries to find that street by clicking on a map, and after the click the game will display how close the user got to the truth. I use this map, and this is also the reason why I built this map, to learn street names from my city. But I think you can also use it as a great way to practice Shiny if you just got started with it. You will notice that this video assumes that you already have all the map data you need. So today is only about building the app and not dealing with how to get the map data. For following along my steps you can always use my dataset that I link in the description. If you want to extract that data yourself, you can always check out my separate video in which I show you how you can do that with R by connecting to OpenStreetMap. I will put a link to that video into the description, and I think with that we've covered all the preliminaries we need, so let's get started building a Shiny game. Alright, I've got a basic Shiny setup here. More or less I've just created a new Shiny app via RStudio's menu, and then I've just erased everything from the default. First thing we need to do is to get our data into our app. You see here in my working directory I have street lines and background maps. These are both RDS files which contain the data on the street lines, the geometric lines, and the background map. So we can get them into R or into our app with the reader package, and once we've loaded that we can read them outside of our UI or server. We will need this data anyway in all cases, so we can just read them at the beginning when our app is initialized. So we need street lines, and if we take a look at street lines, then we see that this is basically a really large data frame, and we only need two columns out of it. So we need the name column and we need the geometry column, which contains, well, the actual geometry. We can use dplyr for this. Let me load dplyr, which will give me the Magritte pipe, and will let me use select for name and geometry. Okay, so this is better now, and because my geometry column contains geometric information, we will also need the SF package, which is basically ours package for working with spatial data. And sometimes, this is why I'm loading it right now, functions like select or filter or other functions from dplyr may behave weirdly when one column of a data frame contains geometric information, because that is stored in a different format, and this can cause issues. So just make sure that library SF is actually loaded. And with the same logic we can just read RDS, use read RDS to get our background map. Now that we have our data, we can set up our user interface. Here I want to do something really simple, so let's just start with a fluid row, and then I want to have a free color layout, basically where the two outer columns are just white space, so all of our content is concentrated in the middle column, which is, I think, nicer to read. So do column 2, so a column of width 2, a column of width 8. This is where all our content will be in the end, and then we'll have a column with label 2. Let's fill our middle column with a headline, so that you can see what I mean with this white space. Let's load this app. And if I make this app, this window a little bit larger, then you see here on the left hand side there's white space, on the right hand side too. I think user interface is just more legible if you don't use the full window but just the middle part. Now let's add what we will need later on. Our game will consist of a button that is pressed to sample a random street. Then we'll need a text box that will show the name of the street that the user is supposed to look for. And then we will need, of course, the map the user can click on to make his guess. So these are three things we need, and we can just throw them into our middle column. So let's start with the action button. Let's use an internal name button for this. And we label it by what is it supposed to do, which is just draw a street. So this is what it will do. Then we will need a text output. I like to use verbatim text output because that puts a text around the box, which I think is nice. Let's call this street text. And then we will need a plot output for the map. Plot output, let's make this map. If we load this up, we see that we have a button now and everything else isn't there yet. So to show you how it works, let's just put some default values in there. So street text will in the end be rendered via render text, and here we'll just put some default text in here, and the same for the map. Of course, then we will need to render plot, and let us just use ggplot as a default. If we want to use ggplot, we'll also need to make sure that the library is loaded. Of course, we will need to spell library correctly, otherwise we'll get an error. Nice. So this is our main interface, so to speak. And what I want to do before I forget is to tweak the user interface a bit more so that it is kind of consistent with my standard. Because what I like to do in Shiny apps is that I want to add an about page. The about page basically contains all the information I want to present to a user that finds my app. Just, I don't know how he finds it, but he or she has landed on my app. And then in the about page I want to say this is licensed under whatever license. You can use the code freely, you can find my other stuff here, just giving it some context, because I think it's a good practice to do. The way to add such an about page is via tab set panels. So let us do this. Use tab set panels. In the documentation you find the basic structure. You use tab set panel, and then you can have tab panels for each step. So let's put tab panels here. The first one, of course, will be about the game. So we can put our stuff in here. And the second tab panel will be my about page, which can use the same design, but of course we don't need this stuff here. We will need, actually I like to format this a bit differently. I will do it in a sec. I want to include a markdown file, which is just which is called about.md. And if I want to do that, I will also have to have such a file in my working directory. So let's call this about.md. And here I can just put in regular markdown text and give information on my app. If I let me style this code a bit, I like to use the tidyverse style. So I have an about page now and a game page now. this is something I just find neat. One more quick change we can make, but which can really influence the overall appearance. Let me say that again. One quick change that we can do to change the overall appearance of our app is to set a theme. And a theme can be set with the bslib package, which lets you implement a Bootstrap theme really easily. You can set up some background colors, foreground colors, have a primary colors, and then you can choose some fonts for your base text, your codes, or your headings. I like to use the same fonts and the same colors every time, and I've actually documented them in an old Shiny app. You can find it here. It also has an about page where which I use to demonstrate how my app works under the hood. And there I've also put in this theme, my theme setting that I like to use, and I will just put it in here. Now let's reload our app. And I like to think that this has a more personal touch and looks nicer now, and it's not really a lot of effort to make this work. And now we can start working on our server logic to get things working here. One thing I should mention before, we have added this about page via include markdown, and for some reason when you want to upload your app to Shiny Apps.io then to publish it there, you will need to add the markdown dependency because for some reason it doesn't, Shiny Apps.io doesn't automatically find it and your app will crash on their server, but for our case, for our local server here, it doesn't change anything. Alright, that said, let us start by making sure that there's actually a street name sampled here that is displayed in this box. Let's start by declaring a reactive variable called street name, and in there we just do regular tidyverse stuff. We filter first to make sure that we actually sample something what has a name. Not all streets have names. I think in the data set these corresponds to like large motorways that do not really need a name, but I'm not quite sure. In any case, there are NAs in this data set, so we make sure that we do not by accident sample these via filtering before that. And then we can slice the sample. We only want to have one, and then we need to pull the name. Alright, now we can display this street name here, and you see we actually sample the street name here and it is displayed. But of course this only works once when we reload our app, which is not really great. Let's map this to, or let's bind this to the button, and it's really easy to do this. We just bind the reactive to an event, effectively making it a reactive, an event reactive, and this is done by bind event and binding it to the input button. And now it works. Whenever we press the button, we get a new street, which is good. But what I don't like about this is that this box doesn't appear at first, and then it moves the map down. To make this a little bit more consistent, I like to make sure that the map is only displayed once a street is drawn. And we can do this here by requiring that the button was pressed actually. Before that the plot won't be displayed either, and now if I plot this, everything gets displayed at once. See, nothing here, pressing the button, everything there. Great. Now let us map the map. Let us display something there, which is what we can do with ggmap. Let's first just display the background, and if I want to use ggmap, I need to have the library as well. Pressing the button should show me a map, but I think it's kind of small, so let me make this a little bit larger. For now, let's just fix it to 600 pixels. Later on we will make this dynamic, so the height of the plot changes depending on the width of this window here. The next step is to draw the street lines of Ulm. As you can see here in the map, we have Neu-Ulm here as well, and I don't want to learn streets in Neu-Ulm, so this is why my geometric data contains only information about Ulm, and I can add separate lines with gmsf, making sure that the data is, let me move this up a bit here, that the data is the street lines data set that we've declared earlier. And since we're using ggmap, we also have to make sure that we don't inherit the statics. And now you see that we have drawn lines for all the streets that belong to Ulm. This up here is Blaubeuren, which doesn't belong to Ulm, so it is still gray. But one thing I want to make sure of is that the lines are a little bit thicker. So let's change its size to 1. Okay, this looks better now, and we can start working on making this interactive. So something should actually happen when when someone clicks the map. Before I do it, let me, just like I did with the render text, let me move the actual computation outside into a variable. We'll make this a reactive value. Reactive value, and then there I will put in my code. The reason why I make this a reactive value and not a reactive is because I want to set the initial value, and I want to really, with my code, make sure that I set the value of that reactive every time. And with reactive, you cannot explicitly change the value via code. This is done with reactive val, and this is why I use it here. So this plot variable is initialized with with this value here, and now I've, in the actual plotting part, in the render plot, I only have the variable name. It doesn't change anything in our app later on, but now I can change this variable depending on what happens in the app, what the user clicks, and I don't have to blow up my render plot part here. Okay. To enable that map clicking is actually possible, you have to define a click variable in plot output, and we'll call it map click. And what I want to do now is that when the map is clicked, then we actually plot a point right there where the user clicked. So let's do it. We want to make this dependent on a click, on an event, so we will need to put everything into an observer, and tie this observer to the event we want to use as start. It's a start for this observation, and in this case it is not the button but map click. And in this case it is just an update of our plot variable. By adding a point to it. So we need to have a data point, which I will define in a second, and then let's make this point larger and maybe make it red. But of course I have to define this point first, and this can be easily computed via the inputs, so we can access the x and y coordinates that the user clicked on via accessing map click, and from that accessing the x coordinate or the y coordinate. We will need to do both and stick everything into a vector. Not 7y. And also I want to make this a geometric object, so I will stick all of that into st point. And when you're working with geometric objects, you will always have to make sure that if you want to compare stuff later on, like the street and the point to compute its distance, you have to make sure everything is in the same coordinate reference system. And here I will make sure of that by setting stcrf. No, what's the command srf? Let me check my template that I built. This stsfc. I always forget it. And the coordinate reference system number I also always forget. And now that we have that, it should work. You can still draw a map, and if I click, there is a point. Maybe make it a little bit larger so we can actually see it better. But now I will click here into the green, and there should appear a red button now. Yeah, perfect. So that's great. We now know in principle how to interact with the map. Now let's make sure that once we clicked, we can see what the solution is. So let's plot the street in here as well. First we need to get the geometric objects that correspond to the street. So let's make this a reactive value, which we can compute based on street name. So street lines Ulm, then we filter to cases where the name equals the street name. Then we pull the geometry. And now what we have to do is to combine it into one geometric object, because a street in the real world can consist out of multiple line segments in the data set. And this is why if we want to get all of the data that corresponds to a street, we'll probably get multiple rows from the data set, and we need to combine it as one. And this is done with st union. And of course we'll need to make sure that it's the same coordinate reference system, and then we can plot this, add the street to the plot like we did before. This is a reactive variable, so we need the parentheses. And let's see if that worked. And there is a street after we've clicked. That's great. Let's see what happens if we draw another street. The solution is still there. So the old click and the old solution is still there. So I want to make sure that my map is put back to its initial state. And we can do it by changing our plot reactive variable here a little bit. Make this plot a reactive value that is empty, and then we tie an observer to the button click, which will update the plot variable. Tie this to the input button. It's button. This didn't work. Of course, we need to use bind event. That was a silly mistake, but it happens, I guess. Okay, what happens now? I click. Okay, there's the Böfinger Steige, and I click draw another street. Everything is back, put back to before. Everything is still working. Nice. Alright, so this puts everything back, and now we can make sure that we get to see how correct or how wrong we were with our guess. What I would like to do is to have a circle here and a label that tells me how close I got to the street. We can do everything in here in this observer. First we'll need to compute the distance between our point guess and the street lines. This is done with st distance, and we can just put in point in there and street. This will compute our distance, and from that we can also compute a circle by taking the point and buffering it. St buffer will make this into a circle with radius distance. Now we can add the circle to this. This is the first step. Circle, let's make it blue. And before we add the label, let's make sure that we haven't done anything wrong yet. Okay, what we will need, of course, is that the filling of the circle is empty, it's transparent, so let's make fill equal NA. And now it works like we want to. Let's add a label via an annotation. I think I annotate. Is that correct? No. This is spelled correctly now. Yeah. Okay. I want to have a label gm. As x coordinates, I will use the map click. Oops, wrong part. As y coordinates, I will use it as well. And as label, I will use distance, but I will probably need to add a unit to it. The distance is given in meters, so let's write this there as well. And also what I'm just remembering is that we do not need really good accuracy. We don't need floating distance to be a floating point number, so let's round this to an integer. And now should work. Okay, we display a label now, but now it's right where our point, where our guess was. So let's move it up a little bit. And there you go. I think our app is functional now. It does what it's supposed to do. Let's have a few trial runs. Kurt Schumacher-Ring, I think that's this one down here. Yes, I got quite close. Let's do another one. I'm not always that good. Okay, Hasslerstraße. I think it's somewhere here, but I'm not sure. Ah, wasn't that bad. In any case, our app seems to work. Now let's fix the one issue that is bothering me, is this white space here. When the window we use is large, it's okay, but when I make a smaller window, then we have a lot of white space here, and it's annoying me. The reason why this is happening is because we've hard-coded the height to be 600, but I would like to make this dependent on the window width we're using. And for that, we can use a little bit of JavaScript magic. And I say magic because I don't really know any JavaScript, so I won't pretend that I can teach you JavaScript. But really, the only thing we need is to add a short code snippet you can easily find online. Add that to our Shiny app, and once you at least understand what this code chunk does, then you can work with just regular R code in your app. Let me demonstrate that R chunk, that JavaScript code that we need. I have it here in my template app, which is this glorious part. We can put it into the header of our tab set panels, and really what this does is it adds, I think what it does, I'm not an expert in JavaScript, is it adds the JavaScript script to your app or to your website basically, and this code here is executed. And you don't need to understand a lot from this code other than what it does is it makes a variable inner width available to your Shiny app, and we can use this new variable in our server function just like we use any other variable by using, do you have an example here? Yeah. By using input, $, and then the variable name. We can do the same thing now by using input, $, and then inner width. And inner width will give you the width of the window we're using. So what we need to do is to compute the height that we want to use later on, and I want to have my map to be quadratic, so same height and same width. So what I need to compute in the end is the width of my 8 innermost columns. And we can do it by scaling the total width of this window by a factor. So let's do this. So we will declare a new reactive variable, no, plot height. This is a reactive now, and in here we can now access inner width, and this can be null, so I need to add a small if else case here. If is null, or I like to do the opposite. If it isn't null, then I will scale it by 7/12, and otherwise this is just 0. And now I make my height to be this reactive. Watch out that you don't try to pass the value of the of this height to this height argument, but what you do is you pass a function to this argument, and the reactive value is a function or a reactive variable. Now let's see what happens. Now what happens if I make this smaller? Then the padding, well, it will get a little bit better. It's still not perfect. Maybe if I make this 8/12, this will get larger again. So let's make this maybe 6/12. It's not perfect, but at least this is now dependent on the window size. This concludes my video, and I hope that you've enjoyed it. If you don't want to miss out on any of my other content like other videos, blog posts, tweets or whatnot, you can always follow me on Twitter, subscribe to this YouTube channel, or sign up for my newsletter. All the links so you know where to find me are in the description. And now enjoy the rest of your day, and see you next time.